Hello and welcome. In our previous lesson, we discussed what a motor is and the types of motors. Then, we talked about motor drivers and motor driver shields. In this lesson, we will continue our motor education with a brief technical overview of DC motors, followed by a sample project. First, I would like to talk about 3 to 6 volts DC motors, which are also used as toy motors. These motors are widely available and serve as a great introduction to DC motor technology. These motors have 2 power connection points on their sides. The rotation direction of the DC motors varies based on these connection points. One of these connection points is connected to the voltage supply, while the other is connected to the ground line, and switching these connection points changes the motor's rotation direction. We will see this change in action shortly in our practical demonstration. Let's briefly look at the features of the motor. The operating voltage is between 3 and 6 volts. The current drawn from the circuit varies between 0.2 and 1 ampere. When we apply a voltage of 3 volts to the motor, it reaches 20,000 revolutions per minute, while at 6 volts, it can reach 40,000 revolutions per minute. The dimensions of the motor are quite small. The motor, which is 25, 15, and 20 millimeters in size, weighs about 15 grams. Its lightweight design makes it ideal for various applications, especially in robotics. We are examining the operation of the motors through the Tinkercad simulation application. The motor on the left rotates counterclockwise, while the motor on the right rotates clockwise. When we examine the motor on the left, we see that connecting the positive terminal of the power supply to the motor's positive terminal and the negative to the negative results in a counterclockwise rotation. For the motor on the right, we connect the voltage or positive terminal to the pin that is normally designated as ground. And we connect the ground line in reverse, attaching it to the red line designated for voltage. When we make this connection, the motor rotates in the clockwise direction. Now, we will practically examine the operating principle of the DC motor. We observe that as we increase the voltage applied to the DC motor, the speed increases. We need to apply a voltage between 3 and 6 volts to this DC motor. We exceeded the maximum operating voltage of 6 volts. Running a DC motor above its operating voltage for an extended period can cause it to overheat and lead to wear on its internal components. When we gradually lower the voltage, we observe that the motor's rotation speed decreases proportionally. Below a certain voltage, around 0.5 volts, the motor starts to slow down completely and tends to stop. Now, let's examine the motor's movement when we swap the positive and negative terminals. After making the connections properly, we can start applying voltage. Right now, the motor continues to rotate in the opposite direction and reaches maximum speed at 6 volts. And when we reduce the voltage, the motor eventually comes to a stop.